Morgan! Alright, I hope you're doing alright. We're sorry you're not with us. We're starting with the grand finale from yesterday, where we learned to take a two-sample Z interval and for the difference of two proportions. And so this was the grand kahuna that we were working with on number 13 and number 14. So on number 13, you had answers. You had answers in the book. So were you able to come up with the correct answer that was the book gave?
The book only gave one answer. Off by like the last decimal. I have no idea where it is.
So on number 13, if you did it correctly, let's tell me what numbers you put in. I'm not going to write them all out just for sake of time. But could you look at your number 13 and tell me what numbers you put where? Shannon?
0.44 minus 0.35 plus or minus 2.58. Square root symbol 0.44 times 0.56 over 2253 plus 0.35 times 0.65 over 2629.
All right. So when you did all that, it should come out pretty close to 0.05. Whoops, this is it. 0.051, 0.123. Is that the right one?
I got like close to those. I got
okay,
0.13.
I'm okay with close to that.
Yes.
How did you get the Z score? Because I got something right.
All right, the Z. What was the confidence level? What did you use for the Z score, Shannon? What was your?
2.58.
All right.
I used 0.57.
All right, yeah, that's all. Okay, so let's go over that. We'll answer the question. How do we get a Z-score when it's not the one we memorized, which is 1.96 for 95? So, Maggie, Haley, could you get me some water?
Yes.
Maggie, what is the confidence level?
Is it 99?
All right, so you understand that when it's 99, this has to be under there. So how much is out of that area? 1%. And then that's going to be split between two sides. So 0.01 becomes 0.005.
Yeah, that's right.
Yeah, 0.005. So that's half of 1%. So you have to look that up in the body of the chart.
It's in the body of table A, right?
Yes, table A, because we're on P, we're in proportion land, so that's these scores. Thank you. All right. All right.
How can I ask a quick question?
Yes.
So I was I don't know, I was off by more than one. I got 0.054 and 0.126.
She said it fine.
Yeah, you're in the third, you're in the hundredths, so I'm okay with that.
Did you ever find out how close AP you have to be? Like, would that be acceptable for AP?
Yeah, I haven't, so I do want to look that up before, when I'm training you.
Okay.
We will find the answer to that. It should be fairly easy to find. All right, so that's going to give you the number 2.5. I used 7. You used 8.
Yeah, I
Is
used
that
7.
right? It must have been in between. So 2.57 or 2.58. What did you use, Haley, for Z star on number 13?
2.57.
Okay. All right. So we are 99% confident that the difference between the two proportions in this problem lie within that interval, which is 5% to 12%, basically. All right. So let us then talk about how to get that out of your calculator. So then I'll ask you to do number 14 on your calculator to check your own work. So let's do I'll train you on 13 and you will check 14 on the calculator. So you will go to Stat Tests.
Two variables.
And I'm not sure, some of the little phrases seem appropriate, but you're going to have to go down to number B. You know how it goes 1 through 9 or 1 through 10 and then starts A, B?
I did not know.
We're going to go down to B.
That's a number B?
Two prop.
I know, but I
Yeah.
know.
Can I borrow that calculator?
Yeah, Yes.
Great.
Is
Thanks.
yours done?
2 prop Z
It's
int.
downstairs.
Oh, okay.
It's
Stuck in the
wait,
abyss.
what was it called last year?
I'm in the abyss.
The abyss.
Now,
There's so
I,
much in the hole.
I like to
Oh.
try to find things on
I'm
my
down in the
calculator
abyss.
without being told, just to get the skill down.
Wow.
And I thought there was a
Do you
very
really?
appropriately named one above that, but it wasn't right. So B is the correct one, and it will ask for x1, n1, x2, n2. So Shannon, what was the sample on X, the first sample for 13?
0.44.
No. Oh wait, I thought you said the same.
The sample.
The
Is that what you
yeah.
mean?
No.
22,
It's like how
53.
many?
22, 53.
What, we're doing 14.
No, N.
No, we're doing
N,
We're
13.
doing 13 right now.
N would be 2253.
All right, 22, 53.
Yes.
Is it
And what was
986?
X?
X
What
is
is-
how many? So
What
no,
percent?
it's
Nine-
not.
So
986?
hat. It's not 86.
Is XP hat?
986?
Yeah,
Is it the percentage or the
It's
number?
whatever number you put over 2253. I don't
Yeah.
have it before.
Oh.
That's 986.
Here's how we could figure out
No,
the,
you get that
the
when
value.
you multiply.
So
On
986.
that one.
No, yeah,
I gotta look
986.
where the data is.
Because that's what you put over 2253, I think.
Oh wait,
To
is
get
it?
0.44.
Is it 986?
Is it the number?
986.
Okay,
So
that's the number
Yeah,
of
Drew's right.
men.
that wasn't
Actually, it's
given.
986.
That wasn't given.
That was given.
It was.
It was given, we just didn't know what
that's
X
also
was.
what you get if you multiply 2253 by
Right.
0.44.
Oh.
986. Yeah, you're working backwards because you got the proportion
Really
by
going backwards.
dividing this by this. So 986. So x2 would be 923, and n2 is 2629. Then you hit enter.
Wait, do you have
What
to
is
put your
the
confidence,
C level?
confidence
Oh, we
level?
do? Yeah,
C level.
99.99.
That's what it was already for me.
You get it as a decimal, I believe.
Oh, I got P hats now.
Look at these little tiny
Alright.
pea hats.
Oh wait,
You gave
it's
me
in
a
the whole
different
thing.
answer, kind
He
of.
has 1 and 2 and ends 1 and 2.
Yeah, and
Oh.
I got the 2 numbers. Is it?
Oh yeah, I got those numbers on here.
Right, this is what
Oh,
we,
Miss
that's
Powell,
what
this is so
we're-
much easier.
Morgan, look at these little
Alright,
tiny pea
now I
hats.
want you to take this skill and go to number 14.
Wait, can we confirm the right answer for 14 first? Like for...
No, I'm
No.
here to
She's
confirm
gonna teach
it
us
right
everything.
now.
I'm gonna
You're
check.
going to confirm it on the calculator.
Okay.
Are you calculatorless? Alright.
No, I have.
Maggie, can you share?
Yeah.
I'm just looking.
Alright, so now go over to 14.
Yep.
We're going to go stat test, number B again. Alright, so
Wait, I gotta look at my book
X1
to find out what that is.
and 1. Dan, can you
Okay.
help us figure out what numbers to put in our calculator?
Yes.
What would
Go to
X1
test.
be?
And then go down to B.
Oh, this one, sorry.
Uh,
Yeah, this one's my sheet.
56.
Are we doing men first?
And then
Men
you
We're doing-
minus
we're
women?
fill
doing
in
men
all
first.
of your
Okay, so
information.
how
Yeah,
many?
Daniel, that's
Go
N.
down to the bottom.
No, that's
Oh,
that's N.
so men, 46.
46?
46.
Alright.
With the number of
Alright,
people
and
yes.
N1, Dan?
Or the number of
63.
Oh, wait, yes.
X2?
27.
And
More
N2?
men said they were
56.
Alright, so number 14, and what percentage are we
90.
confident? 90.90?
part of this problem.
I got... Boom.
Alright, check what you got.
I got very close to what I got in real
very
life.
close to
Very close is good.
I got
95?
Very close
In
is
the
good.
calculator,
90%.
you get 104.75
And
That
that
was
was
X1
and
and...
.39128.
46.
Okay,
Calculator.
63.
That's what I got on my calculator.
X2 is 27.
So,
And
and your work should be confirmed. Is it?
Yes.
Yeah.
Okay,
Man.
alright. So I will take those up then, there's only 2. And I will go on to teach tests. We're gonna do a stay in P land, so you're still on your
Is this
same day notes.
Day 2 of the day 1, 2, 3.
Yeah, it's the cram.
Is this a quick
The
unit?
cramps.
Yes,
Remember she said she's taking the meat out of them?
yeah.
Oh, I don't.
Taking all the important meat.
boneless.
What?
No chicken here.
Boneless
Boneless
What year
unit.
was this?
Alright.
This patent
Yeah.
He's not like on the back.
I don't.
He
It
did
ended
it.
like one
Okay.
day the AC was out. And
Alright,
You did not even do the right
I
one.
remember.
You actually.
No.
So look, I have like all the tables.
Ryan, I feel like I'm gonna be a 76ers fan.
Are anything different, or are they all?
I'll be living in Philly.
I think they're all different.
I-
I'll break it.
All right. I'm going to erase the board, and you are going to recognize and find a spot on the same note-taking page. I wonder where you could put it, because what was that? Teens versus adults? Yeah. How about on the back?
It just takes a picture of every board.
On the top, is there a little bit of note-taking room there? Okay, let's go to the back, on the top. So, Joel, can you show Morgan what I'm talking about?
Yep.
Morgan, we're still on the day note 1/2/3. And we are going to be looking at, we're going to stay in P land, just like yesterday.
She wants us to work.
Yesterday we did a confidence interval. Today we're going to do a test. So we're going to do a one. Let's talk about 4. 4, we had a 1 sample.
Like a big pink silver inside your head.
That'd be
Z
nice.
test.
It would take a very.
4P. So remember, this is just what we just had a test on. And here we would always start with a null hypothesis, something like P is P naught. And we'll say the alternative is it's not P naught. There were some other choices.
So this is not review from yesterday. This is new material, right? Okay.
See if you could squeeze it in at the top there.
Before the hungry children.
Yes, right before the hungry children. So, we learned that you would do the Z statistic. Let's say alpha is 0.05. You would do the Z statistic, P hat minus P naught over square root of P naught 1 minus P naught over N. And that number would be our Z score. Where would we go with that number? Do you recall, Maddie, what we would do?
Table A.
Right, table A, and we would get a value from table A, and sometimes we would be happy with that value, and sometimes we would have to augment it. Because I said not equal to, Joel, do you know what we would have to do with that p-value?
Multiply it by 2.
Actually, we have to do something else, because...
Oh, 1 minus.
Right, first of all, it's only going to be giving us that value because it's going to be lower than some number, and we're interested in this part.
Yep.
So it's going to be 1 minus the p-value doubled in this case. All right, so that's what we saw earlier. And then we would compare P and alpha and go on from there. All right, so let's...
Miss Powell, I have
yes.
a question about last night's homework really quick.
Uh-huh.
So, on part B of it, it was like, is it convincing evidence or not? And it, in the back of the
I
book.
said it was 13 and 14.
Yeah, part B.
Yeah, they have.
Yeah.
They said, is it?
And
There
the
was
back
a
of the
part
books.
B. I didn't want you to do part
yeah.
B.
Oh, well, I
Oh.
Because I
Okay.
didn't.
It just
Did
said
you have
like
to do a test?
no.
No, it
It
just
just
said-
said, is there convincing evidence? And
Oh,
then we had
sorry.
to decide yes or no. And the back of the book said like there is convincing evidence because 0 is not in the
Oh,
thing,
yeah,
but
yeah,
like
So there is convincing
I
evidence
just-
that there is a difference.
All right, let's go back and talk about
Okay.
that just for a second. Go to the front of your page. I'm glad you brought that up. Notice in the exam, what is the first example we did? It was
Teens
the
and
teen
adults.
minus adults.
Yeah.
And the confidence interval we got was 22% to 30%.
Yeah.
And notice what we were saying the difference between the two was in between those two percentages. What if 0 was in that confidence interval? Then we would be saying that P1 minus P2 was 0 is a possibility, and that means there's no difference between the two. So sometimes they will ask you, looking at a confidence interval like this, oops, I erased it. If there's a confidence interval, say like this for they'll say, is there evidence that there is a difference? And the answer is yes, because 0 is not in there.
Okay.
So if it goes like this, minus 0.05 to say
7.
point, to not, I want to go positive, 0.01, something like that. Then 0 is in that interval, so it is possible to say that there's no difference, because a plausible answer is 0. Can you go back and make a note of that in that part? So,
Yeah.
so like where it goes teens minus adults was 22% to 30%, 22% to 30%. That indicates there is a difference. And then maybe just put, for example, if the interval was like that, negative 0.05 to 0.01, which is negative 5%
So
to positive 1%.
if the interval doesn't contain 0, then
Right.
it has convincing evidence?
Right.
Okay.
All right, so there is a difference. No 0.
So if it doesn't have a negative number, and it's
Yeah.
probably not gonna.
Right, that's true. 'Cause how else are you going to get 0
There's
unless
like-
it starts right at 0?
Like, there's still a difference.
Right.
Like, negative 0.05 minus 0.01 is
Yeah.
a negative
Yeah.
0.05.
But there's no chance of there not being.
Chance of there being.
All right, for example, if this is a confidence interval, 0 is in there. So there is a possibility.
Possibility.
That there is no difference. All right, and you know that's what happens when I draw out the meat. Some of the crumbs get left on the floor, so that was a crumb that's
Meat
worth
crumbs.
mentioning. So thank you, Shannon. All right. So again, recapping, when we do confidence intervals, if it contains 0, there is a possibility that there's no difference between the two proportions, and they may ask you that. All right.
Ryan, draw meat crumb.
All right, moving right along, we're going to upgrade to
Wait.
2
Michael,
sample.
wait, what's your name?
This one should seem more familiar because we just tested 2 sample. Z test. Four.
Also, one more question about the before land of the Z test. Is it, if you sub 1 minus p-value, do you always multiply by 2?
No, only if it's two-sided, they're not equals. If it's greater than, you are just going
The
to
two things you're
do 1
comparing.
minus.
P1 and P2.
If it's less
Is there
than,
ever,
if it's less than, you're going to
Because
keep
if
the
they're
number
the same thing,
unchanged.
1 minus
is
the
there
other
ever a chance that you'll multiply by 2 when you don't subtract?
I can't think of one.
Okay.
Doesn't make sense to
Yeah.
me. All right, 2 sample Z test for the difference between 2 proportions. So you'll recall that first of all, we set up a hypothesis and then we check RIN. So the hypothesis, we're going to say is P1 minus P2 equals 0. And that is saying that another way you'll see that sometimes you see is this the same thing as P1 equals P2. So you can see it stated like that. You're basically saying your null hypothesis is there's no difference between the two. So you're going to gather evidence against that.
evidence.
Got that? All right, now P1 minus P2 we'll say is not equal to 0. There are other choices. I'll teach it with the is not equal to 0. So let's talk about RIN. All right, again, AP takers and even final takers, if you forget RIN, you don't get a whole lot of credit. So make sure, there's no use doing a test or a confidence interval if it doesn't meet the preconditions. All right, random, similar to yesterday. All right, check both. Check N1 and N2 for random. Check N1 and N2 for random. So you're gonna hopefully it states that it was a random sample for both. Independent, when we're looking at that, it's very similar to yesterday. If it's an SRS, then you do the 10% rule. 10 times N1 is less than the population N1, and 10 times N2 is less than the population for N2. So nothing really different there from yesterday. If it's not an SRS, you have to use your brain and analyze the situation to make sure that there's independence indicated. All right, it's almost always an SRS, but sometimes it's an experiment. So you might say, does drinking coffee for the first guy affect the second guy? That kind of thinking.
Miss
So,
Powell,
yes,
are you a judge for the science fair this year?
I am not.
Okay.
Are you in the science fair?
I'm not.
Okay. All right, normal.
That'll be fun
All
to
right,
judge.
N1 times P1,
I Miss Powell.
and that has a hat on it, is greater than or equal to 10.
Say her name.
N1, P hat, 1 minus P hat.
So what is the difference between this and what you were asking me about earlier with
I'll
the
tell you
After the lesson.
And
I see your,
N2, P hat 2, greater than or equal to 10.
Okay, bye.
N2, 1 minus P hat 2 is greater than or equal to 10. Right? So we have 4 steps just to find out if it's normal or not. Now, do you recall how that differs from what we did over here? We didn't write it down over here. Let me go back and do that. Rin, again, is random
Ryan cleans his room, so let me see.
for N.
Let me see your composition.
I, again, for an SRS, was 10 times little n is less than big N, equal to. But what did we do over here on just on this most recent test?
See what you guys are doing. You made me go.
We did what, Haley?
is this we did N times P naught is greater than or equal to 10, and N times 1 minus P naught is greater than or equal to 10.
All right. All right, so notice I didn't use
P
P
naughts.
naught over here. Why not? Why did I not
Why
use
not?
P naught on this? This is what we did last week or a couple weeks ago. We took this test. We used P naught. Why am I not using P naught over here? What is
P naught
P
is
naught?
0.
What's P naught?
0.
It's
0.
French for peanuts.
So would that work? Could we do n times 0 greater than equal to 10? It's not going to work. Then we would have n times 1 minus 0, which is not going to be, could be greater than depending on the n size, but this would never work. So over here, it was appropriate to use P naught because that was what we were assuming to be true, P naught. Over here, we're going to use P hat, which is the result from our sample taken. See the difference?
Yes.
All right. The differences are going to keep coming on this side, so this is going to be not as intuitive as it was yesterday when we did the confidence intervals.
Miss Powell, can I have a
Yes.
tissue?
Yes, you may. All right, certainly. Here's the test. We're going to come up with a Z statistic.
Are those for Puffs Plus?
They are, but I don't see any others, so
Wow.
she's special.
Plus she
All
got
right.
her glass of water.
Because she's been top dog.
All right, so I still have that box and another, so I'm doing good,
Oh,
Diane.
okay.
All right, so here's the test statistic, which we're going to calculate. We're going to go to chart A, because this is a Z test. Proportions are always Z tests, not T, but Z. We're going to go to the A chart, and we're going to do just like we did over here in one sample. Here's how we calculate the Z statistic. Instead of P hat, we're going to have P hat from the first sample minus P hat from the second. Probably doesn't surprise you because we're looking for P1 minus P2. So that's going to happen right there. Then we're going to subtract. Here we subtracted P naught. Guess what we're going to subtract here? We're actually going to subtract 0, so there's nothing, because we're going to subtract what we
So we
call,
don't write that.
I'm not writing my
Yeah.
S 0.
it's 0 because of that.
It's always minus
Yeah.
zero.
I already wrote the minus.
Are we
so-
only going to be looking? Oh yeah, we'll only be looking for the difference here.
Yeah. So things are a little different. So it should make some sense until we get to the denominator. Over here, look what we have. Over here, it is different.
0.
Sorry, no 0, but PC, which I haven't taught you yet, over 1 minus PC
I'm noticing
over
this P character has a
N1
lot of kids.
plus PC 1 minus PC over N2.
Okay.
All right, you haven't seen that yet. It's brand new.
It's brand new.
Okay.
All right.
I feel like you have shown us something with the C and I can't
I
Take
can't
your
remember
computer,
either. All right,
Multiplied by
this
1 minus
is
your computer.
red.
Yeah, because like C also stands for
That has a name.
Yeah.
That P sub C is a name. It's called the pooled proportion.
There's something else with the C.
Stupid commercials.
Proportion.
Wait, what? I never seen that. What's a computer?
Like that.
What are you doing on your computer?
Pooled proportion. And I call it the combined proportion. I don't know why they call it pooled and there's a C. So I think of it, instead of pooled, I think of it as combined, because P sub C makes sense.
Why is it
How old was that
why is it
person?
added spelled like a pool?
That's how it is, pooled.
That's so weird.
Pooled.
That's like carpool.
Not like, yeah, it's not like pooling and pushing, it's like jumping in a pool.
It's like when you push your friend in the pool and you say, you got pooled.
Yeah.
And
So,
they-
I
When were
think
you ever comes out in
technically, its name is pooled proportion, but I think of it as combined proportion. Now, what is PC? Let me tell you. PC equals x1, that's the number in your first sample, x1, plus the number in your second sample, that's x2, divided by
We're in your third.
n1 plus n2. That number is PC.
So it's not the number of people in the sample, it's the number of people who like agreed with it or like the survey correctly.
I don't know, it's like the total of number of successes from both divided by the total number.
Okay, so it's the same X that we put in our calculator.
Yes, it is. All right, so that is the model. That will give us, once again, now we're up to here. We've got a Z-score. Yes.
Is this whole right half now? Because we did before
Yeah.
and this
Yeah.
This is the next.
Okay.
This was before, and this is
Instead of
now.
before and
There you
after.
go.
No, Dan, don't you remember learning this?
All right, so
I didn't know
now
if this was
we
like all
have.
before and we haven't even gotten to now.
Yeah. No, you're not that.
We already learned this.
You're not that confused. We have never seen this
You're not that
before.
dumb.
All right, so this gives me the Z-score, and I'm going to take that Z-score. I'm going to go to chart A,
Shove it in table.
and if for this one, I'm going to subtract 1 minus that and multiply by 2. So nothing changes after we've got the Z-score. So I'll just say, etc. It really depends on whether you have a greater than or less than or not equals to.
Wait.
Etc.
What happens in the etc.? I'm sorry, I was confused.
It's
If you have
just
this,
stuff.
like 1 minus.
Oh,
Say they
right,
were the
right,
one
right,
minus
right.
or the
It
two
depends on
times.
if it's never going to be one-sided. Oh, it might be one-sided.
It could be. It's almost always not equal to in our work. Yes.
Can I go to the bathroom?
You may.
Will we still do the 2 times 1 minus whatever we get if it is
Yeah.
not one-sided?
Yeah.
That's not that easy.
Okay. All right. So let's do hungry children.
So
Are you ahead?
All right. I'm gonna erase the before because I need to jot that
Put in your
down.
planner,
Pretty
Danny.
good.
For band names.
Go ahead and write down
Erase your paper.
Write down the Z statistic, write the formula for hungry
I
children,
always count one as my own.
and begin. Let's go ahead and start by calculating
Hungry children.
PC.
One
That would be a
toilet, not
good
to eat.
start.
Let's start by doing rinse.
Yeah, yeah.
That's the same right.
Thanks for doing this.
I don't want to hear you cry.
Let's start.
Dark humor is like food. Not everybody gets it.
All right, what we're gonna do now on hungry children we're going to set up the hypotheses, then we're going to check RIN. Then we'll do the pooled statistic. All right, ready? Ready or not? RIN. All right.
Here we rin.
All right, would you read it for us? Kevin, read about hungry children. And if you come upon RIN, if you come upon random, I'll check it off. Go ahead.
Okay. Researchers designed a survey to compare the proportions of children who come to school without eating breakfast in 2 low-income elementary schools. In SRS,
Yay. So there's one check.
of 80 students from school 1 found that 19 had not eaten breakfast. At school 2 in SRS, of 150 students included 26 who had not eaten breakfast. More than 1,500 students attended each school. Do these data give convincing evidence of a difference in the population proportions? Carry out a significance test at the alpha equals 0.05 level to support your answer.
Okay. Yeah. All right, so here we go. We're going to run down an example of all this theory. So we start with random. I heard him say random twice. This is my shorthand. On the test, you actually state random samples were taken for both.
Can you just say
Independence. Independence, and this, they were SRSs. We are checking 10 times what and 10 times what in this case. Dan, can you pick out the numbers? 10 times.
It's 10 times, the first number was 19.
This is the whole this is the whole sample size.
80?
Yeah. So that will give us a number greater than 10, and then the other one, Dan?
150.
Right, and that will give us a number greater than 10. So
We don't.
Wait, no, it should be
That's-
greater than
that's
the
not good.
population.
Yeah, greater than big N.
It's less than or equal to big N.
What are you?
Which is greater than 1,500.
Yeah.
Because it gave us
Yeah.
that.
All right. So we're saying there's
Why
more
is it
than
every time I
800
need to put
students,
something
and then we're saying there's more than 1,500.
That's a lot.
What
All
is
right.
big N?
How many students?
So both schools have more than 1,500
Like
kids?
Yeah, we're assuming that. And in fact, if you were working for a
1,500
statistical
students is a lot.
company, you would actually write that in your report.
Public elementary school.
Okay.
That's pretty good.
Assuming there are more than 1,500 students, we can rely on this data. So, all right. So let's go on. Now we have all of this to mess with. So let's see if Ryan, you can pick out the numbers. N1 P hat would be what?
N1P hat, let me look. 19.
All right, and how'd you get that?
That might be right. That might be you right.
How'd you get that?
You said 19.
He's
Then
right.
it wouldn't be 19, it would be 80.
Oh, N1, not X, Ryan. N.
You're right, it's 80.
All right, so what two numbers? What's N1?
80.
What he said.
Are you all right with that?
Yeah.
Okay.
Yeah, I think so.
And P hat is point. Oh yeah, we should calculate P hat.
We need to do the math.
It's a
All right, P
0.24.
hat
It's,
1
0.24.
And P hat 2.
It's 0.17.
So P hat 1 is what, 19 out of 80,
0.24.
and that's 0.238, I'll say. And then 26 out of 150.
173.
173. All right, so I need to calculate those numbers. They are from my sample. How many successes out of how many in the first sample? How many out of the second sample number? So these are my P hat 1 and P hat 2. So now P hat 1 is 0.238. But you see how if I keep it like this, if I keep it as a fraction, you can see quickly that it's 19. And 80 times 1 minus 0.238, I got 61. All right, so then we have to check it for the other sample. 26 out of 150 times, that's the P hat, times 150. You can see quickly that it's 26. And then the 150 times the balance of 0.173, which is, I don't know,
So
124.
you want us to go to the third digit, even in checking for normal?
Probably not, as long as I'm not, because as long as it's greater than 10, we don't.
Because we're already given one of the numbers.
Yeah.
Given
you're
one
only
half
given one
of
of
the
these
numbers.
numbers.
Yeah.
Alright, so we are greater than 10 on all 4 counts. Questions where I'm getting those numbers, this is the time to ask me and nail that down. Alright. Let's go ahead and figure out P sub C, our new friend. The pooled proportion.
Did we make our
So-
hypothesis already?
Oh yeah, we should do that next. Alright,
Good idea.
We should
so
do that.
we'll get there. Alright, I did
Do
say
we-
we'd do that
wait.
next, but I started
There's-
down another rabbit hole. So
there's
what
no
is
need to-
PC? Andrew, can you pick out, having never seen before, how to do PC? What
Yes.
X1 is and X2,
X1 is the 19.
right, and X2?
26.
Right. So this is the number of, we call successes, whatever the problem is. The number that were drawn from the first sample that said whatever we were looking for. We call it successes, and 26 from the second. All right, and Andrew, what goes in the denominator?
80 plus 150.
So that's not so bad, but it is an aggravating, picky thing that you have to memorize.
How
And
many-
the only time you use PC is it's 2 samples Z test for
That's
P1
so-
minus P2.
I'm
I
not
know.
going to be able to do that on our AP. Oh my goodness.
Isn't that awful? All right, so you can do it, but can you remember all of it? That's the question. All right, now the moment we've been waiting for. The null hypothesis and the alternative hypothesis. Go ahead of me, and write out what you think the 2 hypotheses are.
I need more like signature.
All right, and by the way, when I calculated PC, I got something, 0.196.
Yeah, I got it.
Okay.
When we make the H around each obey, do we actually put in P1 and P2 and what they equal? Or, okay.
It's because they're unknown. P1 is for the whole population. Are you filling in what you think H sub O is?
I don't know what it is.
And H sub A, I'm asking you to do that ahead of me. Here, you can look over here for a little help. All right, so H sub O is we're making the null hypothesis is P1 minus P2 is 0. So we're saying there's no difference between the children, the proportion of children from school 1 and the proportion of students from school 2.
How did you know that? Just because they're doing 2 tests and they don't think it'll be. Wait.
Neither
We
one know it.
always start with that hypothesis.
Oh,
There's
okay.
no difference. We're doing 2 samples. We're interested in the difference between the 2. So we always
Right.
start with that there is no difference.
So H sub O will always be that.
Yeah.
Okay.
All right. Now H sub A, P1 minus P2. We'll say, was there any indication that
No,
it should be greater
just
than or
says
less
difference.
than?
No, it just says difference.
Different, all right, so
So
that
it's
is
not
not equal to. Sometimes there's an indicator word which would force you to go greater than or less
So
than.
it would be greater than or less than if it was like we
More,
expect
if they
this
say-
group to eat more breakfast, not eat more breakfast, be better when you eat
Yeah,
breakfast.
they would have some indicator.
Okay.
So they probably would need one. All right, numbers. All right, Bree, I'm going to write out the equation. I'm going to erase this RIN. And I'm going to ask you to pick out some numbers for it. So we want Z equals P hat 1 minus P hat 2 minus 0 over P combined or pooled 1 minus P combined over N1 plus P combined 1 minus P combined over N2. All right, Bree. What numbers should we grab?
P1,
Is
0.24.
I'm gonna put 0.238.
So should we
Okay.
use 3 decimals?
I would recommend it.
Okay.
Then our answers will be more like each other. All right, keep going, Bree.
Minus 0.173.
Good.
You said 2, 3. Okay.
All right, and the bottom.
Over the square root of 0.196
All right.
times 1 minus 0.238, which
is that
no.
1 minus
PC.
this C is this number is always the same? In that way, it's easier because on our confidence interval, we had different numbers on both sides of that plus sign. We will down here, but the numerators are going to be alike. Little break. All right, so you okay with this, Bree?
Yes.
All right, divided by?
Is it 80?
Yeah, the
Okay.
first school. Uh-huh. And
And
then?
then that plus 0.196 times 1 minus 0.196, which is 0.804
All right.
over 150.
All right. All right, to save time, I just went ahead and did that calculation, and it is 1.182. And now we are going to go to chart A.
Oh, that's the after the division, I think.
Then we're going to go to chart A, and that is a Z-score. So we're going to look in the column, the margin.
I got 1.274.
I got 0.013.
If you carried the 3 decimals beyond the zeros, you
I
should
did.
get this.
Yeah, I did that.
Did you?
I wanna
Well,
see
I'm
what
not
you
going to
get.
go figure it out. Sorry.
On your own.
All right. Anyone get this number? Not that you have to calculate it. Let's pretend this is the number. All
What
right.
did you get?
23.
1.182.
Did you get 0.881?
Yeah, I got what you got.
Yeah, Abraham Lincoln.
So we're going to go to
Okay,
chart
wait,
A,
I don't-
and that is going to yield a area like this. That is telling me that I want all, this is the Z-score is 1.1. So it's about here on my conceptual chart. So this is telling me the area that I've striked to the left of this line at 1.1 is about 88%. So what will I do with that number? Kevin, what will I do with that number if that's giving me this and I want 2 tails? I want this
You
tail.
have to subtract 1 times 2.
Right. So subtract this number from 1.
It's gonna be 30.
Wait, I thought we only had to subtract if it wasn't. Oh, because the table only gives us less than.
Right.
Right. Okay.
I always draw it so I don't get confused. I don't memorize that. I just kind of conceptualize it.
And we.
So we want 2 tails.
Wait, why are we multiplying like?
Wait.
Oh, because it's equal to or
Since
not
It's
equal.
on both sides.
Yeah, because of this. And these tests with 2 proportions almost always are 2-tailed. Almost. All right. So we're going to compare. What do we get when we do that? I got 0.238. All right. So that's our p-value. So Maggie, tell me at the 0.05 significance level, what do I do with a p-value of 0.238?
Do we fail to reject?
All right. Because this is very plausible. This could happen 23% of the time. This happens. So therefore, we have no reason to reject this. So therefore, we fail to reject. And I'm going to continue saying, remember, when we don't reject this, we're saying there's not enough evidence to say this. So we fail to reject saying there's not enough evidence.
It's the worst when you move on from a chapter and
To
you're
say
but the next chapter just like builds off of it and is the
there
same.
is a difference. And I ran out of room between the 2 schools' proportions of breakfast eaters. Okay. All right, did you follow my conclusion? All right, this is sort of like last chapter stuff. From here on in, this is the stuff that's different, the computation. All right, calculators out. Let's try to find this one on our calculator. Go to stat tests. And this time we're going to go down to number 6.
2 prop Z tests?
Yes, two sample proportions, Z test.
Wait, is it going to give me a graph?
No?
It doesn't normally ask for a color. Unless it gives me a graph.
Yeah, you can choose to either calculate or draw.
I guess.
It's just gonna give you the answer
Yeah,
in green.
it's giving me the option.
Okay,
Yeah,
good draw. That's always fun. I like draws.
Wait,
Like-
which one are we picking?
6.
6.
Number
Stat
6.
test number 6.
Stab test.
So, this is when we're doing a test. When we did an interval, remember we went down to B. So we're doing number 6. I plugged in the numbers. I plugged in the numbers 19 from the first sample, total in the first sample, successes in the second sample. Does it ask for anything else? I don't think so. All right, so do we get a Z and a P similar?
I
to
got
This
this?
is a little bit off.
No. I got
Z equals 1.16.
Yeah.
Or 1.17.
I got Z equals 0.8.
And we got 1.18.
Yeah.
P equals.
All
Okay.
right, so close enough. Pretty cool.
It's kind of
We have the same conclusion.
Since we're
Wait, I wanna see
All right, so you're going to do 17A,
Marguerite.
17A, and 22.
All of 20.
22 you'll see is an experiment. It's not an SRS. So we're going to do 17A and 22.
Does that mean we don't write a null hypothesis and stuff for it?
It'll be the same,
What did you
except you know how an experiment has like a control and it has a non-control. So you'll have two groups just like this.
So 17A
And 22. 17A and 22.
Are we gonna have like